Hey, what's up everyone? This is Physics for Engineering, and today our task is how to transfer the maximum heat. Let us imagine the following. We have two bodies. One body is cold and has zero temperature, and the second body is hot and has temperature of 90 degrees. These two bodies both have the same mass, same volume, same density obviously, and same specific heat capacity. And our task is what is the max amount of heat which can be transferred from the hot to the cold body. And we have a following condition. So we can contact these two bodies for the heat transfer. And the second condition, we can cut the hot body in several pieces. Why is that? Why we need to cut this hot body in several pieces? Okay, let's check it out. So let us take these two boxes and then let us move the hot box towards the cold box. Just after the contact, the heat will transfer from the hot box to the cold box, and after some amount of time, the cold box will be heated and the hot box will cool down, so that the temperature of these two boxes will be the same. Now the question is, if the initial temperature of the left box was 0 degree and the temperature of the right box was 90 degree, what is now the temperature of these two boxes? Obviously, this is the 45 degree, just the half of it, because the mass and the specific heat capacity are the same for these two boxes. But this is our intuitive feeling how to solve this task. We write the amount of heat which is transferred from the hot body to the cold body, this is Q2, and the amount of heat which was taken from the hot body to the cold body, this is Q1. Let us say this is the left body and this is the right, because the index 1 and 2 we need for the temperature before and after the contact. And then with the consideration that amount of heat which is given by the hot body is equal to the amount of heat taken by the cold body with the opposite sign, we can solve this problem. And this is the answer. Considering that the mass and the specific heat capacity of these two boxes are the same, we can easily calculate that the final temperature of these two boxes is 45 degrees, exactly as we expected before. Okay, what is the point? So let us now do the following. Let us now take the same initial condition, these two bodies, one is cold, one is hot, and now let us cut the hot body in two pieces, in two equal pieces. And now we will move each piece of the hot body towards the contact body one by one. First we move the one piece of the body. After some time the cold body will heat and the hot body will cool down and the temperature will be equal. We can do the calculation in the same way as before. What is the temperature now of these two boxes? This is 30 degrees. And now as a second step we will move the second piece of the hot body to the cold body. After some time, the heat will transfer to the cold body and the temperature will be equal. Let us now then calculate what is the temperature now of these two bodies. We can use the same way as before. Using the same method as before, we can easily calculate that now the temperature of the second body is 50 degrees. That's already interesting. This means if we cut the hot body in two pieces and contact one by one to the cold body, then we can heat the cold body from 0 to 50 degrees, but not like 45 degrees as before. This is interesting, isn't it? If we do now a quick summary, so if we have one body and we want to transfer the whole heat to the cold body just by contact hot body to the cold one, then we can increase the temperature of the cold body from 0 to 45 degrees. If we now cut the hot box in two pieces and contact to the cold body one by one, then we can heat the cold body to 50 degrees. This is what we just solved. We didn't solve today, but if we cut the hot body into the three pieces, then we can heat the cold body to 52 degrees. So obviously, if you now keep doing the same thing, transferring the heat from the hot to the cold box, and cut the hot box into the more and more pieces, then we can achieve higher and higher temperature of the cold box. So now the question is, what is the maximum amount of heat which can be transferred from the hot to the cold body? If we can contact these two bodies and we can cut the hot body into several pieces. So let us now solve this problem. Again, we have two boxes. One box is cold, has a 0 temperature, one box is hot, has 90 degree temperature. Let us now cut the hot box into the many pieces. we can now contact each piece of the hot body to the cold body and transfer the heat from the hot box to the cold box one by one. And we consider that we cut this hot box into infinite number of the small boxes, so that dm would be the mass of the one small piece of the hot box. Then amount of heat taken by the cold body would be dq1, which is equal to the specific heat capacity of the cold body, the mass of the cold body, and the small amount of temperature that cold body increases after the contact with the small piece of the hot body. And dq2, this is the amount of heat transferred from the small hot piece to the cold body. It will be product of the specific heat capacity of the hot body, the mass of the small piece of the hot body, and the temperature difference of the small piece of the hot body before the contact and after the contact of the cold body. Considering that these two amounts of heat are equal with different sign, we have now the equation that we can solve. We will split the variables to the left and to the right side of the equation and take the integral. The integral is simple and we have a constant which we will find from the boundaries. We have the following boundaries, that if the mass of the hot box is 0, then obviously the temperature of the cold box remains 0. Then we take T temperature from these equations and get the final result, so that the final temperature of the cold body has exponential dependency. Now, with consideration that we have the same specific heat capacity for the two bodies and the same mass, we obtain the final formula. So we get the result that our final temperature of the cold body is the product of the initial temperature of the hot body and 1 minus 1 divided by E, where E is the exponent of the Euler number. This is nice, isn't it? Let us now take 90 degrees of the initial temperature of the hot box and calculate what would be the final temperature of the cold box. So using our equation we have 56.89 degrees. So this is the max temperature which can get the cold body being heated by the hot body, which is cut into the infinite number of small pieces. And this is the answer of our problem. Okay, so let us now do the following. So we will now investigate how we can heat the cold body to the maximum temperature. Let us return the mass in our result equation and imagine that the mass of the hot body is higher than the mass of the cold body. The question is now how big should be the hot body in order to heat the cold body to the maximum temperature. So let us put some numbers in this equation. Imagine our cold body has a weight of 100 kg, and then this graph shows the maximum temperature of the cold body, which can be achieved by increasing the weight of the hot body from 0 to 1000 kg. We can see if the mass of the hot body is same as the mass of the cold body, 100 degrees, then we can heat the cold body to 57 degrees. This is the result of our problem today. If we now increase the mass of the hot body, then we can achieve higher and higher temperature of the cold body, obviously. And with the mass of the hot body approximately 5 times higher than the cold body, we can heat the cold body almost to the initial temperature of the hot body. Let us now think how we can use this result in the practice. Hard to imagine that we can cut some body into the small pieces or into the infinite number of the small pieces, but we can use a liquid, for example. If we have two buses, the one bus has a hot liquid, another bus has a cold liquid. Imagine that amount of the hot water is the same as the amount of the cold water. Then after some time the temperature of these two liquids will be the same, like 45 degrees. If you now develop such a system, as you see on the picture, so that we can transfer the hot liquid through the pipe and by this way heat the cold liquid, then the conditions will be very close as we just solved, so that we will heat the cold liquid in the bus to the high temperature, like 56 degrees. What is necessary to mention here that we consider that our system is completely isolated, so we have a zero heat losses in the system. Okay, this is all for today. Thank you for watching. If you like this video, hit the like button, subscribe, and see you next time.